Alright, let's look at the homework 2.4, problem number 5. Alright, so we have, let's see, position function, f of x equals x squared plus x, and x is a time. Alright, so let's do that. Alright, part A, we want to find the average velocity. X goes from -1 to 2. Alright, so average velocity is the same thing as the slope of the secant line, so we need to have 2 points, right? So 2 points is going to be part A. So first point would be, so x is -1 and f of y is f of -1, and the second point would be 2 comma f of 2, right? So you can think of these as let's see, x1 and a y1, and this is x2 and a y2. Right, we can find the slope of the secant line, which is the same thing as our average velocity. So m, or maybe I should write average velocity is equal to, right, f of 2 minus y1 is f of -1 over x2, 2 minus -1, right? So f of 2, just plug in 2 here, 2 squared, 4 plus 2, so that's 6, minus, put -1, so -1 squared would be 1, plus -1, so that's actually 0. Then 2 minus -1 is 2 plus 1, so it's 3. So this is going to be 6 over 3 is 2. Right? So let's type that in. So answer is 2. Let's check that. Alright, we got that. Alright, part B. We want to find the average velocity for x changing from -1 to -1 plus h. Alright, so it's the same thing. Instead of doing a 2 and a -1, we're going to have a -1 plus h and a -1. Alright, so part B is going to be, this is also an average velocity, and this is going to be f of -1 plus h minus f of -1 over -1 plus h minus -1. Alright, so we can simplify by canceling -1 minus -1. Alright, then f of -1 plus h would be, we just have to plug in -1 plus h squared plus -1 plus h. Right, then minus, right, f of -1 is actually 0, right? Then divided by h. Then we can multiply out, so this is going to be -1 squared would be 1 minus 2h and plus h squared, and plus we have actually -1 plus h, right, and all over h. So we can cancel +1 minus 1 there, and combine those together. We get the -2h plus h would be -h, and there's a h squared over h. We can factor out h from the top, so h, you have h minus 1, then divide by h. Alright, so we can cancel h and h, and we get h minus 1. Alright, so let's type it in. Alright, so we got h minus 1. H minus 1. Let's double check. Alright, we got that. Alright, instantaneous velocity at x equals -1. So this is the same thing as slope of the tangent line. So all you really have to do is just take the limit. So instantaneous velocity would be limit as h approaches 0 of the result from part B. So h minus 1. So this is going to be 0 minus 1 is -1. So instantaneous velocity is -1. Alright, let's check the answer. Alright, we got that. Alright, that's it. I hope that this was clear.